Start. Yeah, you in the back row. Okay, so I'm really pleased to introduce Francesco. So I think, as everyone's aware, the capacity program, we have sort of money to invite visiting speakers to come and sort of talk to us all about things relating to monitoring and pollution. So Francesco is our first seminar speaker. So Francesco is from Trinity College in Dublin, where he's an associate professor. And I was learning this morning that Francesco's looked at a wide range of sort of different problems. He's looked at air, water, and even soil. So I think what he's going to do this afternoon is try and give an overview of some of that work. The idea is for an hour he's going to sort of give a presentation on the work that he's been doing, and then from 3 o'clock till 4 o'clock we have the room booked, and we thought that if people want to stay we can have some more general discussion, going into things in a bit more depth. So on that note I will hand over to Francesco and
Thank you.
To learn about what he's been doing.
Okay. Thank you very much for having me here. My name is Francesco. I work in the Department of Civil Structural and Environmental Engineering in Trinity College Dublin. I've been working there as a lecturer for the last 18 months, and my work is mainly based in in the field of advanced spatial analysis. For most of my work I'm using a GIS, Geographical Information System platform, as you can see from the picture I'm displaying there. And I'm applying basically different models for air quality, water quality, water storage, noise, and so on for different kind of environmental pollution, as for speaking. I'm trying to integrate them into a GIS platform in order to have like a better and easier communication with which would be the end users of the tool I'm producing, so planning authorities. As most of the planning and local authorities. So most of the local authorities in Ireland would have like all their data sets in GIS format. So what I ended up thinking is that, I had a lot of issues at the beginning trying to translate their data sets into a suitable format for my models. So my final decision was actually that it would be easier actually to adapt my models to their data sets in order also to produce outcomes that would be easy to use for them at the end of the day, because they'd be my clients. So I'm modeling environmental pollution using a GIS platform, and I'm producing results that they are usable again on a GIS platform. So they are easy to interrogate and easy to use for planning or policy issues for the local authorities. Okay, so in specific, I'm doing, as I was telling Alistair before, I'm a bit all over the place at the moment. I'm working in different fields. As I said, I'm working in the field of air pollution. I'm doing a lot of work in pervasive sensing, work that I started during my, my first love that I had, like while I was working in MIT. I started working with sensors. I gotta be interested in the field, and so I've been carrying on that kind of work also at present time. I'm working in the field of water. That is, it came with the position I got. At the beginning, I was just mainly focused on air, noise, and sensing. Then the position I was appointed to was involved the study of water pollution. So I got also interested in that field at the moment. As I said, noise, creating GIS tools for local authorities, so decision supporting tools. And I'm doing other research in different fields, in energy, transport, and so on. Okay, what I'm going to do today, I mean, lucky you, I prepared an awful lot of slides, but I don't want to bore you too much, so I'm going to cover just the first topic in detail. I'm going to touch a bit the sensing part, and I'm going to keep the other slides for the other fields for our meetings for tomorrow and meetings that I'll have with you on tomorrow and Friday. So I can show you some picture of the work I'm doing in Trinity, the projects that I'm carrying out at the moment. So you will have a better feel of how I can be useful to you. Okay, so we can have a discussion. You can see what I'm doing, what is my expertise more or less, and how I can be helpful. Okay, so just what I mean is that don't be afraid to ask questions. I'm more than glad to collaborate. So please ask questions. If you have any troubles, get in touch with me, and then I'll leave you all my contact details. So we can have either contact me by email or get in touch on Skype. So there's no problem. Okay. So about my experience in air quality, it all started with my PhD, which I started back in 2009, and it was about it was part of a bigger project funded by the Irish Environmental Protection Agency, a project that was called its acronym was PALM, which stands for Personal Exposure Activity Location Model, and it involved basically the modeling of air pollution, outdoor air pollution, indoor air pollution, then as a second step to model the personal exposure of the Dublin city inhabitants, both outdoor and indoor, and validate the model, both models, with a measurement campaign that was carried out as a third PhD program. Okay, so my part in the project was mainly about creating an air quality model for Dublin city, and from there to move to a personal exposure model for the outdoor environment. Okay, I carried out part of my project during my visit in MIT, where I built a few of these models that you see here, which I will explain in more detail later on. But basically, as part of my PhD that was, as I said, related to the personal exposure, in particular to PM10, I had to create a background pollution model, traffic pollution model, a dispersion model for point and area sources, which they will all used as an input for, to evaluate the pollution at street level, and use it for what it was called PALM GIS personal exposure model, which was basically just as a matter of fact, it was basically to model the exposure of Dublin city inhabitants to PM10 while they were outdoors, so basically when they were commuting from home to work and from work back to home. Instead, the other PhD student was more looking into the indoor pollution, so whenever they were sitting in office or back at home again. Okay, so in that way we were trying to cover the personal exposure of Dublin city inhabitants 24 hours a day, 7 days a week. Okay. Okay, so I thought it might be beneficial if I explain the work that was involved into creating an air quality model for the city of Dublin, because as I understand, some of you might have to do the same thing for York or other cities around the world as part of the CAPACITIE project. So I'll give you some ideas of how I carried out this task and how I solved different kind of problems. Okay, so whenever I started my PhD, the first issue I had, it was that in Ireland there was no data available for air quality. So there was no emission database, no detailed emission database for any pollution sources. There were no standard models or no, official models for the air pollution in Ireland. So I had basically to start from zero. And as I was under certain time constraints, I had to be quite pragmatic about it. So I just tried, my first approach was actually to understand how to divide, to split the huge task of creating an air quality model for a city in small tasks. Okay, so basically what I did at the beginning is that I tried to divide the total levels in the city in different kind of sub-levels. Okay, as a matter of fact, basically, if you think about the street level concentration of a pollutant, this is actually the sum of different pollution contribution, okay, which will be from what is called some kind of regional pollution, so from sources that they are not in the city itself, they might come from far away, okay, so from air masses moving also from overseas, okay. Then you have contribution that is mainly related to what is going on in the city itself, so you can call it as some kind of a background pollution within the city. So they be levels that I mean, if you're just looking at the background pollution in the city, it's a pollution that would not change too much over the year, okay? So it would actually be the part of the pollution that would have a bigger impact on the health side, you know, on the exposure of the people, because it be some kind of constant level that be like lingering in the city for a longer time, okay? Then you have like other contribution that would be from area sources, as I said, and peaks from streets with heavy traffic and so on, okay? So what I did is that, as I said, I fragmented the task in a smaller task that would have like an easier solution, instead of targeting the bigger task altogether and maybe starting with a detailed emission database for a city, which was not feasible for me because it would be a huge task that would have maybe required 2 years of my time just to do that, okay? So I decided to approach it from a different point of view, okay? So once I kind of decided the approach I was going to take for the modeling part, I just divided again my modeling procedure in smaller tasks, trying to make it feasible, a lot of smaller feasible tasks, okay? Again, this is just basically a flow chart for the model that I created for my PhD. I figured out that basically in order to create my models, I needed a certain set of data sets that might be, certain data set that hopefully they would be available from the local authority or the local environmental protection agency. So I tried to actually decide a set of models that would use the same data sets in order to reduce the volume of work and so on. So then I just started to identify a suitable model for each part of the pollution that I had to model to have the final total level, a street level, okay, of the pollutants. So basically, I figured out that I needed a different model for the background pollution, a different model for the pollution due to traffic sources, and so on for area sources and point sources, which the results from which by putting them all together would define the total pollution level around the city in Dublin. Yes? Model, now I'm just keeping it general because at that stage of my project it was just as an algorithm. I still had to decide if by model I would use an existing model you know, proprietary software or so on, or if I had to generate the model on my own. Okay.
Is the model a data of, is it a model of some kind of data, or is it
It is also it's a they are, as you will see later, they are both model using, like, so as matter to say, I mean, just for speaking, they are, some of them they are statistical models, so I'm using measurements. Some of them they are dispersion models, so I'm using algorithms. I know the emission from, you know, I don't know, traffic sources, so I'm using algorithms to predict the dispersion of pollutants. Okay, so it's just that, yeah, I'm keeping it a bit general because at that stage of the project I still had to identify which way I would go for each of the fraction of the pollution that I was going to model. And again, one of the requirements of the model of algorithms that I had to use, I would have to use, it was that they would have to be all compatible with a geographical information system, because that was the constraint that I had in my in the project. Okay, so okay, yes, that's more or less the flow chart, the decision flow chart that I created at the beginning of my project, which is basically broke down my project in different tasks. What I'm going to show you now actually is how I generated the background pollution model. This was basically what I tried to do at the time is that I wanted to use whatever resources was accessible for me at the moment, at the time of the project. And in specific, at that time of the project, the EPA had a few monitoring sites for background pollution around the Dublin area. So basically, they were monitoring stations that they were providing daily averages for different kind of pollutants, and luckily also for PM10, a few of them. So what I decided to do was to have a look at which sites would measure PM10, which site could be actually characterized as background pollution, so they would have, they would not be impacted too much by traffic sources, and create a statistical model for each of them in order to have an idea of the background pollution at those sites. Okay, in particular, okay, here I have the size that I've used. What I wanted to do is then create, as I said, a statistical model to also predict the pollution at the background pollution those sites a few days in advance. Okay. Unfortunately, what I was given, as you will see, it was a horrible time series for each of the monitoring sites. Unfortunately, each of the monitoring sites for background pollution had different problems. As you can see, the time series are, I don't know if you can see the dates here, they were for like a quite few, they went on monitoring PM10 for quite a long time, some of them. I had like a data set for almost 15 years for a couple of locations. So daily averages for over 15 years, which is very good if you have to build a statistical model. I mean, the more data you have, the better you can calibrate your model to predict future values, okay? Especially if you find a good relation with other variables, such as a different set of weather variables. The only problem I had with these data sets is that, as you can see, there is a lot of noise. There are huge gaps. Here there are a few years missing, here even worse. So they were actually dreadful to work with. So the first issue I had with this kind of data set was that I had actually to make them suitable to be used with a statistical model. Okay. So what I started to do at the beginning, it was that I kind of I applied to the data set a different kind of data pre-processing techniques. I tried to get rid of outliers, which I found out actually towards the end of my PhD that my approach to get rid of the outliers was a bit too crude. So it was actually, I got rid of few outliers that they would have actually helped me to predict some other peaks. Okay, then I had to get rid of a bit of a noise and so on, handling missing data with some with different techniques and detrending the data set. So getting rid of the seasonal trends and so on. Okay, in order to increase the correlation with weather data sets and make them usable to predict pollution 2 days ahead and so on. At the time, I had a good look at the literature in this for these problems, and what I found out is that there is a non-linear relation between PM10 monitored values and the weather variables. So what I figured out is that a standard regression or multiple regression might have not worked well to simulate the pollution at the different monitoring station, and also to predict the pollution at different monitoring station. So what I decided after cleaning the data set and making it a bit more usable was to use probably the most suitable modeling, if you want, approach was to use a artificial neural network, which tend to be very suitable to model a non-linear relation between data sets, which was the case for PM10 and weather data. Okay, I had to decide also which kind of weather data I was going to use, because what was available at the time was weather data for 2 different monitoring stations around the city, which was not ideal, especially for wind speed and wind direction, because it might change, especially in an urban area, might change from point to point quite significantly. But anyway, I used those. I used a wide range of weather data, such as wind speed, wind direction, temperature, humidity, what else? Rainfall, and of course atmospheric stability classes, which are very important for this kind of models. So I was able to find to get quite surprisingly good results for the 4 monitoring stations. So the artificial neural network model I created for the 4 monitoring stations was actually able to it was actually quite reliable in predicting the PM10 levels at the monitoring station 2 days ahead. I got good results. For me, at some extent, I mean, I was at the time I was using a toolbox within MATLAB, which to me just looked like a magic box, if you want. But it was providing very good results, so I was very happy with that. But again, at the same time, as I said at the beginning, I was only predicting the background pollution at the monitoring station, which is not the background pollution all over the city. So it's just background pollution, as I said, at the monitoring sites, which will not even well distributed around the city. So there was kind of an issue, if you want, with the approach I took at the time. But as I said also at the beginning, background pollution tends not to change a lot over space, okay? Especially in a confined space like Dublin. It's not a whole country. I mean, if you're looking at a whole country, you might have a significant variation from point to point. From the city point of view, there are small variation that I tried to pick up by basically, I'll show you later, interpolating with different techniques, interpolating the results between each monitoring station. Okay. As I said, yeah, the artificial neural network model worked quite well, but still had some issues. Again, I have a feeling it's all coming down to the very bad technique I used to get rid of the outliers, and also to the gaps that were in the data set. So especially where there were gaps or huge peaks, the model was not able to simulate it well. But as you can see, it was I mean, the blue line are the measured data sets. The red line is the model. It was quite able to pick up the variation, even on the long term. This is just 3 years data, so it was performing quite well. I don't know if you are familiar with the neural network approach, but anyway, the way it works, usually you have like it's if you want to call it like that, a machine learning technique. So the bigger is the data set, the more data you add to the data set, the better it performs. Okay, the way it works, I mean, just to make it very simple, is that you take your data set, a good portion of the data set is used for training the network, if you want, and the rest of the data set is using for the validation. Okay, so that's what you are seeing here, the validation part. So basically, the blue line was taken out from the data set, and then it was just used to validate it with what the model modeled. Okay. So as I said, what I did is that I tried to interpolate using different I just had a look at different ways to interpolate the results from my model, from the model that I built for the different points around the city, to interpolate and have values for all the area around Dublin. Okay, I tried different ways, and at the beginning I just used a very straightforward interpolation. Then it didn't make a lot of sense to me, so I started to take into account other spatial data, so land use and so on. So I tried to change the way the background pollution was changing over the space according to the land use. Okay, which to me made a bit more sense. And to be honest with you, the results were not very dissimilar from a straightforward interpolation. But I guess I should have. I mean, maybe if I added more complexity to the model itself, like I'm looking into at the moment, it would have produced more variation. But anyway, that was what the result of one of the results of the background pollution model I created for the city of Dublin. That approach was also initially used to produce the air quality index for health for the Environmental Protection Agency, which was the main sponsor of my project. Now we have like a postdoc working full-time for the EPA, and she's working at producing an air quality model, prediction model for Ireland. And as part of her modeling work, she's producing like tools to generate these air quality indexes for all the countries. So they basically changed the initial approach I suggested with another one that I will explain in more detail later on, and also Professor Broderick will give you more details about that tomorrow. Okay, so what you will see is that most of the traffic pollution models you might have to use as part of your modeling tasks would actually require the background pollution as an input for the model, okay, in order to produce an estimate of the pollution at the street level. So what I did is that, as I said, I used the outcome of this model as an input data for the second stage of my modeling procedure. Okay, so to model the pollution at street level, model the dispersion of pollutants generated by traffic sources, and so on. What you'll find out is that this task will actually require a lot of data pre-processing, because the dispersion of pollutant in an urban environment is affected by a lot of parameters, which would be, the main one would be, of course, weather parameters such as wind speed, wind direction, and rainfall, but also another important parameter would be the geometry of the city. Okay, so it would be the geometry in the way of the ratio, the buildings in the city, so how tall they are, but especially also the ratio between the building heights and how wide is the street, because that would actually create what is called an urban street canyon. Okay, it's basically what happens whenever you have, like, this is a Western Road, a road around Trinity College that we use for most of our monitoring and modeling experiment. We use this road for a particular reason, because there are like a lot of high-rise buildings and the road is pretty narrow. So what happens is that in this kind of road, as I was saying, that is usually defined as street canyon, whenever you have the wind flowing perpendicularly to the street canyon within a 30-degree angle from the axis, okay, and the wind speed is generally higher than 2 meters per second, you would have some the creation of recirculating vortexes within the street canyon. Okay, and this is very important whenever you're modeling the dispersion of pollutants, because what will happen is that if you have like a monitoring device on one side of the road and on the other side, and another one on the other side of the road, what you will see is that the pollution levels will be significantly higher on one of the two sides of the road. Okay, just because of this recirculating vortices. Okay, so whenever I start modeling the pollution within the city, I had to take into account this phenomenon in order to have reliable outcomes from my models. And what I found out is that, I mean, at the time I decided to use this particular model that is called OSPM, Operational Street Pollution Model. That is a model that it's produced by the Aarhus University in Denmark. I decided to go for this model because my department had a previous experience in using this model, of course, and also because it's an extremely fast model. So I was able actually I ran a simulation for 10,000 road links, and to monitor, I think, the hourly levels for a day, and it was able to run the simulation in a few minutes. So it's a semi-empirical model, and it's very fast. So one side I would recommend it for modeling, pollution, street pollution in a city environment. From the other side, it has some issues, especially with the data compatibility. At the time, actually, I had to face one of these issues that was actually trying to get the buildings within the OSPM model, which is not straightforward. I found out actually that was not actually straightforward at all. It was fine for the previous project that were carried out in my project, in my department, that were actually modeling the dispersion of pollutants for one road link. So you had like 10 buildings, so you could input them manually. But when you are talking about a city, so you are talking about thousands of buildings, compatibility with existing data sets is actually an issue. So unfortunately, OSPM is not compatible with any other data set that you might have. Okay, it looks at buildings in a weird way with angles and facades. That is, is nothing you would see in any other software. But the guys in Aarhus University, they came out with a conversion tool. So now it is possible to import your building geometry from ArcGIS into OSPM, and it's a pretty straightforward process. So now it's actually a good model. I would actually recommend it now as a model to use. And of course the guys in Aarhus are also very extremely helpful. So, but anyway, for this kind of model, you need you need not too many inputs, okay, which is good, because some other models that I was comparing, I was looking at the time, they required a very detailed emission database, very detailed traffic flow, and other stuff that would require a huge work just to prepare the model to run. Okay, for OSPM, what you require is that you require a few weather parameters, which are rainfall, humidity, and especially wind speed and direction. And then you require some traffic data sets, which are basically the composition, the traffic, the car fleet for your own country or your own city, which sometimes is also available online. Sometimes you just have to modify it slightly. You require some data about traffic flow, which was available from Dublin City Council, from traffic counters. Okay, and then you require then basically the model itself as inbuilt the Coppert 4 model, so it looks it models the emission from the car fleet itself. Okay, so which it means that the model itself is not too difficult to set up, and is not difficult to use once you have overcome this issue of inputting the data set. Okay. Again, the problem is that OSPM works well for urban street canyons. So what I had to do at the time, it was that look into a completely different model for the rest of the city, wherever there was not that particular geometry which would require a model for urban street canyons. Okay, so basically, whenever you have like your wide roads with trees and nice semi-detached houses around, in that case, the OSPM wouldn't work well, wouldn't perform well. So what I did, okay, this is just a result from OSPM with the predicted levels at each road link, okay, imported in ArcGIS. But what I did for the rest of the city is that I used a completely different approach. I used what is called the general finite line source model. And it's basically a model that uses the Gaussian plume dispersion equation for a line source. Okay. I coded the general finite line source model into Excel and use Python to make it work with GIS. So what I did basically, as an input, I just had to put the emission from the line source, and in the Excel file I had my grid itself, and the Python code was going to calculate, basically extend like the Gaussian equation and calculate the dispersion of the pollutants and the levels at each of the points of the grid. Then again with the Python, it was doing some basic interpolation between the point of the grid and plotting a raster with the pollutant levels generated by this road link in ArcGIS. Okay, so that was basically an easy approach to be extended to the rest of the road around the city. The only problem with this approach, as I said, I was using the Gaussian plume equation, which as you know, is a very simple approach, but it has, of course, it's very simple, and of course it has a lot of limitations, which are basically due to the fact that the Gaussian approach is not, the Gaussian equation doesn't take in account, is not able to simulate, it doesn't take into account of the time that the pollutant spent traveling from the point, the sources to the final receptor. So if you are modeling the dispersion of the pollutants on a long distance, it's basically, you're basically saying that your pollutant goes from point A, from the source, to your destination that might be 2K away instantly as a beam of light, okay, which is not realistic at all. Again, it doesn't take into account by happening instantly, it doesn't take into account the change into the weather parameters, which is, again, if it's traveling far away, is not realistic. But in my case, I was just modeling the dispersion of pollutants in a close range. So it was I mean, the limitation of the equation itself were not having a huge impact on my results. And again, it doesn't take into account of the effects due to buildings. Okay, so it would work well in an open area, open space, which is kind of realistic in the is a realistic description of the suburban areas around Dublin. Okay. But anyway, as I said at the beginning, I was under time constraints. It was just one man working on this side of the project, so I had to make decisions in order decisions, assumptions, and simplifications in order to deliver my projects in time. Okay, so that was one of them. But anyway, as I validated, as I will show now, both models, both OSPM and general finite line source models for 2 different locations, they produced acceptable results. As you can see, I just compared, I had 2 monitoring devices, both in urban and suburban environment, just to calibrate and validate both the urban street pollution model and the suburban street pollution model. They produced this result, like the R square was in the range of 70%, so it was quite reliable. But as you can see, both models, they were not able to pick up the peaks, okay, the big peaks in the monitoring data. I have a feeling, I mean, it's more than a feeling, I know almost for sure that this is due to the fact, to my, as I said at the beginning, very crude simplification, in the very crude way in which I got rid of the outliers, okay? Basically, I assume that some of the monitoring data, they were outliers, but as a matter of fact, they might have been just peaks in background pollution due to a very particular set of weather variables, and I assume they were outliers, got rid of them. So my model, as the pollution modeled by both the urban street model and suburban street model, is a sum of background pollution and contribution by traffic sources. By simplifying so much the background pollution, I was not able to pick up these peaks, because what happened is that I actually, just to make sure that of the mistake I made, I actually compared the monitoring data for both stations, that actually the measurements were carried out at the same time with another monitoring station, EPA monitoring station, somewhere else in the city, and all of them had peaks in the same moment, okay, in the same few days. As you can see, like in the first day of the month, the first 4 days of the month, then again in the second week, and so on. Okay, you can see that they have similar peaks in the 3 monitoring stations. So what I did is that I went and checked the weather data, and what happened is that I had to check basically both to the atmospheric stability classes, which would be very important, would give an idea of the mixing that is going on in the atmosphere, and I had a look also at the rainfall. And what happened is that just in that period when I carried out my validation, something very atypical happened in Ireland. The weather was extremely stable and there was no rainfall at all, which is very typical. My model was not able to pick it up because I got rid of what I thought they were outliers. So it was not able to predict this atypical situations, weather combination or weather variable combination. So I was not able to predict these peaks in background pollution, and that's why the model was not picking up the peaks over there. So long story short is that whenever you are cleaning your data sets, just be careful because sometimes what it looks like a big spike, an obvious mistake of a sensor, it might actually be something else unusual that is really happening around in the environment. Sunny days and no rain, which is not the case for Ireland, as you probably know. But anyway, that's what happened to my. Just probably I picked up a bad period to validate my models. That's it. Anyway, so after that, I extended a similar an approach similar to the one I used for the suburban traffic model, I extended it to model the dispersion of pollutants from point sources, which are a few there are just a few around Dublin. This is the Guinness factory, and these are a few other generators around Dublin. Some of them are not even in use at the moment, but I just modeled the dispersion of the pollutant from them as an exercise, so just to see that I was able to do it. So what I did is that, again, I created I coded my Gaussian model in Excel and Python, and integrated. So I was able to integrate it in ArcGIS, and I used similar approach also. I mean, again, I used the Gaussian dispersion model also to model the area sources. Again, as I said, I had to make this choice to use straightforward models, just because I was just one guy working at the project, and I didn't have a lot of time. Of course, if you have like more people working at the same project, and you have like even more time, there are better approaches than that. But what you'll find out is that sometimes a very crude approach, a very straightforward approach, might produce results that they are quite close to a very refined model. Okay, and sometimes it's just a matter of, for me, it was just a matter of defining the more pragmatic, more time-efficient solution. So there was no point wasting a lot of time in defining a very advanced model, which will give me, you know, results that they would be like 5%, 10% better. Okay, so I just went for, I mean, acceptable results in a very short time. So sometime, especially if my task was to model the personal exposure of commuters, as I said, so people using cars, buses, bicycles, walking around the city. So people actually not sitting on a chair, but moving around. So as you can imagine, you can have the most accurate model that you can ever build, but it might be actually be pointless, all this precision to get, you know, to get a feeling of the personal exposure of people actually moving around in confined environment. They might have single sources, or, you know, even they might be in a car, they might have the windows down, windows up. So there was no point to build such an accurate model, which you know, all this, it just would be wasted for the task I had to carry out at the time. So that's why I went for these more straightforward solutions. Again, for the area sources, as I said at the beginning, there was not much data available at the time when I started my PhD. Much data about area sources. But what I found out is that, by reading the various EPA reports, what I found out is that most of the the bigger fraction of pollution produced by area sources in Ireland, especially in Dublin, was due to residential heating. Okay, so residential heating was actually the main area source for, especially for PM10 in the Dublin area. Okay, unfortunately, again, there was no data, so I had to work with what I had at the time. The census 2011 data was just released, and there was data down to the data about number of houses and number of houses with central heating central heating down to the electoral district and to the what is called a small area, which is a fraction of the electoral district. So we had like data down to that level for the Dublin area. So what I did is that I first of all I calculated the density of houses for a 1K by 1K grid. Okay, so the number of houses in each of these, the density of houses per square kilometer in the Dublin area. From there, I extracted the number of houses per square kilometer which would use the central heating. Okay, the problem at the time is that I should mention that after the 90s in Dublin, it was prohibited to use a fossil fuel and coal and so on for central heating. So I worked. I worked under the reasonable assumption that all the houses that they were using central heating, they were actually using natural gas. Then again, I should also mention that whenever I generated the density of houses per square kilometer, I had also to take into account the fraction of green areas for each square kilometers, because of course the houses would be not evenly distributed over the square kilometer. So I had to make some adjustment to the data set. But anyway, what I meant to say is that the first buyer, when I figured out the number of houses per square kilometer that they were using central heating, the first barrier I had to face, it was that nobody was going to give me the use of natural gas per houses, because it's a commercially sensitive data. So I got in touch with Dublin City Council, Borgash, that is the company that is managing the natural gas distribution in Dublin, and nobody wanted to give me any kind of data sets about the usage of natural gas in a Dublin area. So eventually I was able to find an average use per household, which I had to average yearly use of natural gas per household, okay, which it means that is one single number for the whole year, which it doesn't make any sense. So I had to try to correct it with and to give this number some kind of seasonal variation, because of course in winter time you might use more natural gas for hot showers, urban heating, house heating, and so on. Okay, so I tried to define some kind of seasonal profile to make the consumption of natural gas change over the year for each of his household. Then I used, if I'm not wrong, the Coroner data set to go from volume of natural gas to actually emissions for single households. So what I was able to generate, it was actually some kind of PM10 emissions from residential heating per square kilometer. Okay. From there, I applied again the Gaussian dispersion model also to this problem, because at the end of the day, it seems a bit boring, but it made sense to me to apply the same. Once I figure out a way to do it for a point sources, to apply it for a line sources, which is just a long line of points, if you want, and then apply it again for an area sources, which is a long succession of lines. So basically, what I try to do is that once I produce a model that was working for point sources, I try to repeat the same procedures and use the same algorithms to apply to line sources and also to area sources. So here again was basically an extension of the line, the general finite line source model, and I applied it to an area sources to define the dispersion of pollutants for each of the 1K by 1K elements of my grid. Okay, so to have a dispersion of pollutant over the space from my raster grid here. Okay, so at the end of the day, so I calculated, I had an estimate of the background pollution in a Dublin area. I calculated the contribution from traffic sources with both the OSPM model and the general finite line source model, calculated the contribution from point and area sources around the area, and I was able to have an estimate of the total PM10 pollution in a Dublin area. Here is just some graphics that don't look too much at the levels, but it's just for slides, okay? Just to give an idea. So I calculated the total levels of pollution in each point around Dublin as a sum of the contributions of the different elements that I calculated, like in the different, as you want to say, work packages of my project. Then once that was done, it was the time to find a way to estimate the personal exposure of the people commuting around the Dublin area. So commuting, it means like people traveling around from their homes to their workplace using like different transport modes. So using cycling, walking, driving, getting the train, getting the bus, and so on. Okay, so which just by itself presented a lot of issues. Okay, so what we did at the time, as I mentioned at the beginning, we had like another PhD project that was going in parallel to mine. That the main task of these other PhD projects was actually to measure the personal exposure of Dublin city inhabitants 24 hours a day. Okay, so what this guy did is that he gave this monitoring device, which is called AeroSet, 531, which measure PM10 and PM2.5. Okay, it was given that to different volunteers, which would carry it around for 3 or more consecutive days. So whenever they were walking to or driving to work, they would have this monitoring device with them. Whenever they were cooking at home or sleeping, again they would keep this monitoring device with them. And basically what this guy did is that he collected, I guess, I think is more or less 250 measurement days. He had more or less 70 different volunteers. I tell you, it's a horrible sensing unit. It's very noisy. If you have to keep it in your room, it doesn't let you sleep. So it's very awkward and heavy to carry around. So basically, my feeling is that whenever people were traveling around with this device, they were actually putting that into a bag, stuffing it into a bag, or throwing it in a room far away, wherever they were staying within the house. So we had some issues with the data sets. I mean, some of them, they were actually very interesting because what we, especially for the indoor air pollution guy, because with this guy, what we picked up from the measurement with this device was that the main exposure peaks were during the during cooking times, and also whenever they were, I mean, of course, smoking. That, I mean, it's no need to say that. But also whenever they were hoovering the place or doing something like that. Okay. Again, the outdoor measurements were not great because, unfortunately, the measurement during the commuting phase were very short, because most of the people commuted, like basically traveled for half an hour, top 1 hour, because as you can see from the map, most of our volunteers would just be living around Dublin, as you can see, because that was, of course, I mean, we were looking for volunteers living in the Dublin area because that was the aim of the goal of the project. But again, they were all traveling to the same point. So as you can see, there were all people working in Trinity College. That's where everybody's going there. So they all had similar travel time that were in the range of, as I said, half an hour, 1 hour, which didn't give me a lot of data to work with, you know, to calibrate my model. And again, some of the data was not usable because I have a feeling that, as I said, people were just carrying this, the sensor within their bags, and also because, as you can see, this sensor has some kind of a plastic tube here. I suspect that the measurements of the sensors, as is measuring basically particulate matter, that if you want is just speaking is some kind of dust. The measurement were greatly affected by humidity, because there was a lot of condensation in this tube, what I found later. Obviously, I didn't say to my colleague because that would be a problem with his PhD. But anyway, there was a lot of condensation in here, okay? So I have a feeling that most of whenever you were going from an outdoor environment, so whenever you were waiting from the bus, and then you were walking into the bus, there was a big change in temperature and humidity. So that's when the condensation happened in the tube, and that's when I saw there were problems with the measurements. So that's why I'm saying some of the measurements were not great to calibrate my model. But anyway, that's what I worked with for. What I forgot to say is that the volunteers were also asked to carry around a GPS device in order to track them, and they were also asked to compile a diary. So basically, we knew what was going on. We were able to associate different peaks with different kind of activities. Okay, because and again, this might be another issue because you have to rely on the person who's filling in the diary. Okay, because if it was somebody like me, I was very lazy. I wrote just a small bits of information in the diary, so I don't think my data were great. But so you see, with this approach, there were different kind of issues. What I say, whenever you are relying on a volunteer, then is not part of the project, so that it doesn't have a direct interest in the project. You might have like this kind of issues, like they might be not that reliable. Again, so what I did is that I used in order to calibrate and validate my GIS model, I used I tried to predict the overall pollution. Sorry, on the route that the volunteer was taking from college to home, for example. So I was trying to predict the level. I was comparing that with the measured PM10 levels over the same route, and then this is basically the difference. So what you see is that it was actually very useful to have also the position of the person I was trying to model the personal exposure for, because what I noticed by looking at the difference between the model data and the measured data is that my model had issues, especially at traffic lights. Whenever the volunteer was stopping for long times at the traffic light, waiting to cross the street, it's where there were actually peaks in the personal exposure, and my model obviously was not able to predict those. Okay, so that's something. That was actually somebody I forgot to mention walking. So walking back home. But anyway. I just used a few different test cases. In that case, as I said, here you can see the different peaks at traffic lights. But the model was quite able to predict to model basically the pollution over the path over the route from college to work. This is for the work case. Then I ran the model. I ran the model for different test cases, which would include also cycling home. This is again a model data. No, this is the measured data. Sorry, this is the model data, and again, the model was not able. Was quite reliable on most of the track, but it was not able to pick the peaks. Here there is a big, usually there are queues at this traffic light that is on the exit door of Phoenix Park. And here this is of course Dublin, and this is the Liffey River, and usually it's very busy along the quays, and the traffic doesn't flow, so there are usually a lot of queues around the quays. So the model was not picking very well those, but on the overall again, it had a quite good R-square also for this case, and also for other tests I did with bosses, and the DART was not good. It was not able to predict very well the personal exposure when the volunteer was on the train. And I guess it's because the train is basically a small, confined environment which is moving fast across different kind of environments, if that makes sense. So that was why I figured out probably it was not able to. My model was not able to predict the personal exposure very well. That's our. A few different results. So basically, what I did is that as part of my PhD, I created this GIS model, but basically I kind of defined some sort of framework that the EPA could use to generate a framework that could be extended to other cities around Ireland and also to the rest of the country, which is what is happening now at the moment. Basically, we have like a postdoc working with the Environmental Protection Agency at the moment. And her task is, as I said, is to generate an air quality prediction model for Ireland, and she's using a similar framework to the one I used myself for Dublin. Luckily, we have also a second postdoc that is working at creating a detailed emission database for Ireland, which will make the overall process of creating the air quality model easier, because we have like two guys working on the same project, and also we produce more reliable results because we are also generating a detailed emission database, which make more sense. Yeah, so basically, as I said, at the moment we have like two ongoing research fellowship with the Environmental Protection Agency, which are I mean, there are two projects that, as I said, they are going in parallel. One is looking into creating an urban rural dispersion model for Ireland, and another one that is looking into creating a detailed emission inventory for Ireland, which eventually will end up in creating an air quality model for the whole island, which I think Ireland might actually be one of the only country in EU that doesn't have an air quality model at the moment. So there is a lot of pressure from EU on the Irish EPA for this reason. So that's the work the two research fellows are doing at the moment, and I'll give you just a quick overview of some of the modeling aspects, the modeling tools that they are using. But Professor Broderick is leading both fellowships, so he will be here tomorrow, so he will provide more details. Basically, we are using a similar approach to the one I used for my PhD. So basically, again, we are dividing the overall pollution around the country in different components. And at the moment, what the research fellow is doing is trying to model the pollution, so trying to generate some statistical model for each of the monitoring sites around the country. Okay, so she's trying to produce different models for different pollutants. This fellowship is not only about PM10, but they are also looking into PM 2.5, NOx, CO, and SO2, I think. So they are looking into a range of different pollutants that are measured at different monitoring stations around the country. And she's trying to use different kind of approaches to predict the pollution at those sites. I mean, 2 days ahead. The problem again is that, as you can see from this map, in Ireland there are not a lot of monitoring location. Okay, so here you can see like probably roughly 20-25 monitoring sites, but not all of them will monitor all the pollutants. Okay, so you might have an handful that they are monitoring NOx, some few more PM10, and so on. So the problem we are having at the moment is, again, we don't have a lot of data available, not many monitoring sites, which is definitely a constraint. Okay, the model she's using at the moment, it's a multilinear regression. She's taking also into account air masses, and actually what we are finding is that air model, by taking into account air masses coming from further away, so also from UK and Europe, is actually more reliable in predicting peaks at the station. So basically, it's able to pick. I mean, by monitoring the movement of these air masses, is able to actually predict peaks that my model with the neural network was not that sensible to. You know, again, what is very interesting from air model, from the graphic that you can see here, is that you have actually a visual representation of where the pollution is coming from. So what you can see here is actually, I know I'm not very clear, but what I'm trying to say here is that what you see here is that actually you have a source that is producing pollution that it's 100 degrees from the monitoring station. So it's the approach that she's using is actually very useful to define which sources are having an effect on the local pollution. Because I mean, basically she's using as input for her model, the main inputs would be wind speed and wind direction. So by seeing that and predicting the levels, we can see that there is like for this particular station, we can see that there is a lot of pollution coming from so we have like a quite low wind speed, 4 meters per second. So it means that there is a pollution source that is not much far away, because there is a low wind speed, and it's basically 15 degrees. So you have also an idea of the direction where it's coming from, that is given by the angle of the wind direction, and you have an idea also of the distance, that is a rough idea of the distance that is given by the wind speed. So basically we are using this same approach, well, I'll skip here, to define which are the most important emission sources in a rural area of Ireland, because most of these monitoring sites that I showed here, except the one for Galway, Cork and Dublin, they will be most of them will be in a rural environment. So what we are trying to do is that define, create, as I said, an emission database for Ireland, an emission database that will be for the rural part of Ireland, and an emission database that will be for the urban part of Ireland. Of course, in an urban site, you have more stuff going on, so we are going to produce a very detailed emission database for the urban area, but for the rural area, you might not, such a detail might be not required. So by using this approach, we are trying actually to identify which sources are most important for the pollution levels in a rural area, and so by that we are going to target just a limited range of emission sources for the rural area in Ireland. Okay. But anyway, as I said, Professor Broderick will give you more details about these projects tomorrow. So if you want, I'll just touch quickly sensing, or
should we stop there and
we ask questions? Yeah. Okay.